Today we're going over dilations. A dilation is a transformation that makes a shape bigger or smaller. The words they're going to use is enlarged or reduced. Those are the words they're going to use. Okay? So, go to the second slide. You'll need to pay attention. You're going to see a lot of questions on dilations today that are presented differently that you're going to have to really apply what you know. A dilation is a transformation that uses a scale factor. What do you do with the scale factor? It is a multiplication rule. So a rule is represented like this. The number that they put here is the scale factor. So if they give you the scale factor, you're going to multiply with it. If they ask you for the scale factor, you have to do new over old to get it. Does everybody understand? So that's two different ways they can use scale factor. They can ask you for it, new over old, or they can give it to you and you multiply with it. Okay? Now it says, for an enlargement, the result of a dilation where a scale factor is greater than 1 makes a shape bigger. So an enlargement has a scale factor bigger than 1. A reduction has a scale factor smaller than 1 but greater than 0, like 0.1, 0.2, 0.3. Does everybody understand? So we're not talking about negatives. We're talking about those like the change in your pocket. All right, so let's look at these examples at the bottom, and let's say if it's a reduction or an enlargement. So everybody look at this first one. What is the scale factor? 3.5. Is 3.5 greater than 1? Yes. So therefore that is an enlargement. I'm not going to write the whole word. That's too much. I'm going to put an E. Everybody go with that? Look at the next one. 3/8. 3/8 is a fraction. But you need to know if it's bigger than 1 or smaller than 1. Y'all want to know a trick? If the top number is smaller, then it's less than 1. So I'll show y'all though. 3/8 is 0.375. That's smaller than 1. So this is going to be a reduction. Okay, 0.6. Is that bigger than 1 or smaller than 1? So that's a reduction. 5. Bigger. So that's a enlargement. Okay, 1/5. It's a fraction. Is the top number smaller? Then that's smaller than 1. So this is a reduction. 0.75. Reduction. 10. Enlargement. Now be careful with this next one. It is a fraction, but the top number is what? That means when you divide, it's going to be greater than 1. I'll show y'all 4/3 is 1.33. That's greater than 1. Therefore, that is an enlargement. So the trick to fractions is if the top number is smaller, it's less than 1. If the top number is bigger, it's greater than 1. Questions on reductions or enlargements? All right, turn to the back. A scale factor is found. So if they ask you for the scale factor, it is found by doing new over old. That says new over original, but it's the same thing. New over old. Everybody good with that? If they give you a picture, you take 2 points that are in the same spot. So A to A, B to B, makes sense? And you do new over old. If they give you a table, it's the same thing as a picture, but everybody look. If I want to use X, then I have to use the new X. They're going to give you 2 numbers. You only need one of those. So for example, 8, 12, and 2, 3. If I want to use 8, then I have to use 2. Which one is new? How do you know? It says over here, but what else? The little commas. The commas mean it's new. Does everybody understand? To make a rule, simply do new over old. So up here they did 6 over 3, which simplifies to 2. So your rule would be 2 times x, 2 times y. You're about to do this on your own, so make sure you're paying attention. If you're asked to write a rule, find the scale factor, and then it shows 2 times x, 2 times y. Or right here, look what it was. 2 over 8 simplifies to 1/4, so 1/4 x, 1/4 y. Are we good? All right, let's look at this last part. It says, Alex looked at the dilation on the coordinate grid and determined the rule was 2x, 2y. Alex made a mistake. How would you explain the mistake to him? Okay, well, we got to go see what mistake he made. So how could we do this? Do new over. All right, so everybody find a point. Now, look at B. Is B a good point to use? It's in the middle. I don't really know what it goes to, so don't use B. Would A be okay? Yes, okay. Would C be okay? No. If you use the y-axis but not the x-axis. So let's use A. This is new. It's at what? 1. This is old. It's at? So if we wrote a rule, how would we write it? Take my x and my y and multiply them by, 1/2 x. Let me fix that. 1/2 x, 1/2 y. If you put 0.5, that's perfectly fine. 0.5 x, 0.5 y. So where did Alex mess up? Alex thought the rule was 2x, 2y. What did he do wrong? He did. He actually had the correct numbers. What did he do wrong? A lot of students made the same mistake Alex made. Can anybody figure out what he did wrong? What did he get? 2 over what? Over 1. He flipped it. He did old over new. That is a very common mistake that students make. Make sure the new one goes on top. Okay, I'm passing out your assignment. Put your name, and I am going to help you with a few of them. Is everybody ready? Okay, on number 1, they give you the scale factor. What did I tell you you're going to do? If they give you the scale factor, you are going to multiply. No, they already gave it to you. You're going to multiply. So you're going to take these coordinates and multiply by
4.
So 4 times -1, I would put it here. 4 times -2, I would put it here. Then at the bottom it says, what is the rule? Well, 4x, 4y. I just gave you the answer. Now, quickly, guys, don't keep going. I need to go over each of these with you. Go to number 2. Number 2, ask for the rule. So you need the scale factor. To find scale factor, you need to do new over old. They gave you coordinates. If you choose W, then you have to use the new W. Do y'all see what I'm saying?
Yes.
All right, go to number 3. Number 3 is confusing everybody, but it is not hard. I'm going to give y'all an example, and I'm not going to do number 3 with you, but I'm going to do one just like it. Are y'all ready? All right, number 3 looks like... So number 3 basically says that you have these coordinates, okay? And let's say point D, I'm making this up. I'm giving you an example. Let's say point D is at 2, 3. And it says you're gonna dilate this by a scale factor of A. And then it says, how would you write the new D? What do you do with a scale factor? If you're not paying attention, I'm not helping you. What did we do up here? They gave us the scale factor. What did we do? Multiply. So if they told me the scale factor is A, then I'm simply going to multiply by A. I don't know what A is, so I just leave it as A. Now I call it A because that's what they said. So my new D would be at 2 times A and 3 times A. And that's it. Because I don't know it, I can't actually multiply. I just show that I'm multiplying. That's how you're going to do number 3. Does everybody understand? All right, go to the back. Go to number 9. I'm going to help you set up number 9, and then you're on your own. Number 9 says, using the origin as the center of dilation and a scale factor of 5/2. Now, we're going to multiply with that, right? So personally, I like decimals, so I changed 5/2 to a decimal, which is 2.5. The scale factor is 2.5. It wants you to draw the new shape. Here's the old one, okay? But if I want to draw the new shape, I've got to get the coordinates for it. Do y'all agree? So what is the old W at? -2, comma, 1. Do y'all see how I got that? To get the new W, I'm going to multiply that by 2.5. So I say, well, what is -2 times 2.5? It is -5. What is 1 times 2.5? It's 2.5. Don't take up too much space because you have to do 4 of these. Now I just go graph it. -5, positive 2.5. Here is my new W. Does that make sense? Okay, so you're going to do that with X, Y, X, Y, and Z. And then down here it says, write the rule. Well, they already have the scale factor. So 2.5X, 2.5Y. Or 5/2 X, 5/2 Y, whichever way you want to write it. Okay? All right, get busy.